Good day. I will be your chemistry teacher for this session. Today, we will be discussing on the topic solutions and solubility. Introduction. Most of the materials that we use or see in everyday life are mixtures. They are produced when elements are combined, but a chemical reaction does not take place. Common mixtures include creams, soaps, perfumes, and so on. Solutions are mixtures that look like one substance. Examples include the air we breathe in. It is a solution of a number of gases. The fluids in our bodies are solutions that carry all kinds of essential nutrients and other materials. Examples of household solutions include the following: coffee or tea, any juice, salt water, bleach, that is the sodium hypochlorite dissolved in water, carbonated beverages such as Coca-Cola. Objective: at the end of this lesson, the student will be able to 1. Define some terms in solutions and solubility, describe different types of solution, convert from one unit of concentration to the other, state factors affecting solubility, describe solubility curve. Definition of terms used in solution. Number 1, solvent. Any substance that has other substance dissolved in it. Oftentimes it is a liquid, that is the dissolving medium. The solvent is present in large amount. Number 2, solute. The dissolved substance in a solution, often solid, that is the dissolving particles. Solid and liquid solutes can be described as 1, insoluble, when solute amount is less than 0.1 gram per 100 ml of solvent dissolves. 2, soluble, when solute amount is greater than 1 gram per 100 ml of solvent dissolved. Number 3, solution. This is a homogeneous mixture of solvent and solute. It may be a gas, liquid, or solid. A solid solution of metal is called an alloy. Solution can be 1, concentrated solution. That is a solution that has a higher proportion of solute to solvent. It contains a high amount of solute entities than solvent entities. 2, dilute solution. A solution that has a lesser proportion of solute to solvent. And 3, aqueous solution. A solution in which water is the solvent. Other terms. 4, miscible. Liquids that can dissolve in each other in any proportion, that is, either could be considered the solvent, e.g. water and ethanol. 5, immiscible. Liquids that do not readily dissolve in one another, e.g. oil and water. Solubility. The mass of solutes that dissolve in a given quantity of solvent at a certain temperature. It depends on the force of attraction between the particles. Number 7, saturated solution. A solution in which no more of a particular solute can be dissolved at a specific temperature, or a saturated solution is a solution containing the maximum amount of solute that will dissolve at a given temperature. The concentration of a saturated solution of a solute in a solvent gives the solubility of that solute in the solvent at the given temperature. Number 8, unsaturated solution. A solution which contains less of a particular solute that can be dissolved at a specific temperature. Or an unsaturated solution is a solution in which more solutes can be dissolved at a given temperature. An unsaturated solution is one which contains less solute than it can hold at the given temperature. The concentration of a solution is expressed in moles per dm cube, that is, the number of moles of solute in dm cube of solution. Solutions used in analysis are mostly unsaturated solution. And the final terms, supersaturated solution. This is a solution which contains more of a particular solute that can theoretically dissolve at a specific temperature, or a supersaturated solution is a solution that contains more solute than would dissolve in a saturated solution at a given temperature. Thank you. I'll see you again. Yeah, welcome back. Types of solution. Solutions can be gaseous, liquid, or solid. In general, the physical state of the solvent determines the physical state of the solution. There are different kinds of solution. 1. Solid in liquid solution, e.g., sugar in water, salt in water. Number 2. Liquid in liquid solution, oil in hexane or ethanol in water. 3. Gas in liquid solution. Oxygen in the air dissolves in water. Gas in gas solution, example, air. Number 5. Gas in solid solution, example is solid foam. Number 6. Solid in solid solution, we have the alloys. Solid in gas solution, we have the smoke in that case. Liquid in solid solution, we have butter. Liquid in gas solution, we have aerosol, fogs, etc. There are some forces that contribute to the dissolution of solute in solvent. These are 1. Ion dipole force. 2. Hydrogen bonding. 3. Dipole-dipole forces. 4. Dispersion forces. Now we move on to true solution, suspensions, and colloidal solution. Based on distinct properties, solutions can be classified into true solution, suspensions, and colloid. This classification is necessary to understand the concept of colloidal solution and distinguish it from the rest of the types. True solution. A true solution is a homogeneous mixture of 2 or more substances in which substance dissolved, that is solute, in solvent has the particle size of less than 10 raised to power minus 9 meter or 1 nanometer. Simple solution of sugar in water is an example of a true solution. Particles of true solution cannot be filtered through filter paper and are not visible to naked eye. True solution is transparent. Suspensions. Suspension is a heterogeneous mixture in which particle size of one or more components is greater than 1000 nanometer. When mud is dissolved in water and stirred vigorously, particles of mud are distributed evenly in water. After some time, the particles of this solution settle under water due to influence of gravity. This solution is an example of suspension. Particles of suspension are big enough to be seen with the naked eye, and thus suspensions are opaque. Colloidal solution. Colloidal solution is a heterogeneous mixture in which particle size of the substance is intermediate of true solution and suspension, that is between 1 to 1000 nanometer. Smoke from a fire is an example of a colloidal system in which tiny particles of solid float in air. Just like true solutions, colloidal particles are small enough and cannot be seen through naked eye. They easily pass through filters, but colloidal particles are big enough to be blocked by parchment paper or animal membrane. Colloidal solution is translucent. Concentrations. The strength of a solution is expressed in terms of the amount in the given volume of solvent, which is referred to as concentration of the solution. It is expressed in grams per dm cube or moles per dm cube, or grams per liter or mole per liter. Concentration mathematically equals to amount of solute over volume of solvent. The SI unit of concentration is moles per dm cube. It can also be expressed in percentages. In general, percentages can be defined as parts over whole times 100. In chemistry, we are usually interested in percentage by mass, and percentage by mass equals to mass of the part over total mass times 100%. There are three commonly used percent measurements for concentration. 1, weight per weight. 2, volume per volume. And 3, weight per volume. Weight per weight, that is gram of solute over gram of solution times 100%. Percentage volume by volume is volume of solute over mils of solution times 100%. Weight per volume equals to grams of solute over mils of solution. Thank you. I'll meet you again. Welcome back. Now we go to solubility. Solubility is the maximum amount of a substance that will dissolve in a given amount of solvent at a specific temperature. It can also be defined as amount of solute dissolved in a given volume of solvent at a particular temperature. Solubility is equals to amount of solute over volume of solvent. The unit of solubility can either be expressed in moles per dm cube or gram per dm cube. The SI unit of solubility is mole per dm cube. Gram per dm cube can be converted to mole per dm cube given by the formula concentration in moles per dm cube times molar mass. Now this is a question for you. What is the solubility of 5 grams of sodium chloride in 100 cm cube of water at 25 degrees Celsius in grams per dm cube and moles per dm cube, given that sodium chloride equals to 58.5 grams? Solution. Solubility equals to amount of solute over volume of solvent. Therefore, amount of solute is 5 grams. The volume is 100 grams, so it's converted to dm cube, that is 100 cm cube equals to 1 dm cube. Therefore, 1000 cm cube is equals to 1 dm cube. 100 cm cube will now be 100 cm cube times 1 dm cube over 1000 cm cube, which is 0.1 dm cube. Therefore, solubility in grams per dm cube will be equal to 50 grams per dm cube, while solubility in mole per dm cube will be 0.854 mole per dm cube. Now, factors affecting solubility. Number 1, temperature. Basically, solubility increases with temperature. In solid, the solubility of most solid increases as the temperature increases. In liquid, the solubility of liquid is not greatly affected by temperature. In gas, the solubility of gases decreases as the temperature increases. At higher temperatures, particles of gas move faster and can leave the solution. Number 2, polarity. In most cases, solutes dissolve in solvents that have similar polarity, that is, like dissolve like. Compounds with certain characteristics will dissolve other compounds with similar characteristics. Number 3, pressure. Pressure has no real effect on solid and liquid solutes, but the solubility of a gas in any solvent is increased as the pressure over the solvent increases. That is, the higher the pressure, the more gas that dissolve, according to Airy's law. Number 4, molecular size. Smaller particles are usually more soluble than larger molecules. 5, stirring. It increases the speed of dissolving. Number 6, pH. In general, For an ionic compound with a basic anion, solubility will increase as the pH of the solution decreases. Solubility curve. The solubility of a given substance at a given temperature can be determined from its solubility curve. Solubility curve can be used to determine the amount of substance deposited when the solution is cooled. Solubility of different substances at a particular temperature can be determined. The curved line drawn on a graph showing the relationship between temperature and solubility of a substance at different temperature is called a solubility curve. On a graph, the variation in temperature are plotted on the x-axis and the solubility is plotted on the y-axis. Temperature plays an important role in solubility because the solubility of a substance is different at different temperatures. Importance of solubility curve. Solubility curve can be used to determine the amount of substance deposited when the solution is cooled. Solubilities of different substances at a particular temperature can be determined. Now, the importance of solubility is as given below. Number one, the solubility of a substance at a particular temperature can be determined. Number two, solubility process of a given substance at any temperature can be determined. 3. The solubility curve helps us to predict which substance will crystallize out first from a solution containing two or more solids. The solubility curves help us to compare the solubility of different substances at the same temperature. Number 5 is that it brings the change in the solute composition substance. And lastly, it gives a clear idea that solubility of substance changes with temperature. Thank you, and I will see you again.